Welcome to the session on unitary method, proportion and ratio. The objectives for this session are learning how to define the ratio of two quantities and define and identify direct and inverse proportion and solve real-life problems involving direct and inverse proportion. A ratio is a relation between two quantities of the same kind. It can be expressed as a fraction. The symbol for ratio is a colon. So the ratio of A to B is written as A colon B, which equals A over B. Ratio shows how much of one quantity there is as compared to another, and ratios are used to make comparisons. Let's take a look at this example. The ratio of 3 to 15 is 3 colon 15, or 3 over 15, which is of course equal to 1/5. And another example, if there are 2 boys and 5 girls, we can write the ratio as 2 colon 5, or 2 over 5. Direct proportion is a relationship between two quantities such that if one increases, the other also increases. Or equivalently, if one decreases, the other also decreases. Let's take a look at an example. As temperature increases, ice cream sales also increase. Or, as temperature decreases, ice cream sales also decrease. Another example of direct proportion is as the number of people increase, the work done increases as well for a particular job. As the number of people decrease, the work done decreases also. Another example, as a car's average speed increases, accidents increase. Or equivalently, as a car's average speed decreases, accidents decrease. Inverse proportion is a relationship between two quantities such that if one increases, the other decreases. Or equivalently, if one decreases, the other increases. So for example, as temperature increases, soup sales decrease. Or, as temperature decreases, soup sales increase. Another example, as the amount of snow increases, the number of people driving decreases. Or equivalently, as the amount of snow decreases, the people driving increases. Unitary method can be used to solve real-life problems involving direct and inverse proportions. So for example, if 9 flower pots cost 81 rupees, what do 7 flower pots cost? Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. This is an example of direct proportion. Less flower pots means a decrease in cost. Now the cost of 9 flower pots equals 81 rupees. So the cost of 1 flower pot is going to be 81 divided by 9 rupees. When we decrease the flower pots, we need to divide by the number in question, as the number of rupees, or the cost, will also decrease. And of course, 81 divided by 9 rupees is equal to 9 rupees. So the cost of 1 flower pot is 9 rupees. In order to find the cost of 7 flower pots, we need to multiply by 7. Because since the flower pots have increased, we need to increase the price also, and this is why we multiply. And 9 times 7 rupees is equal to 63 rupees. Let's take a look at another example of direct proportion. If a car travels 200 kilometers on 50 litres of petrol, how much distance will it cover in 9 litres? This is an example of direct proportion. More distance means more petrol. So in 50 litres, the distance covered is 200 kilometers. This is the information we have in the example. In order to find the distance covered in 1 litre, we divide by 50 to give that 1 litre covers 4 kilometers. So in order to find the distance covered in 9 litres, we now multiply the 1 litre covering 4 kilometers by 9 on both sides. To give us 36 kilometers. Let's look at one more example of direct proportion. A worker gets 1,200 rupees for 12 days of work. How many days should he work to get 40,000 rupees? So let's solve this. Again, this is an example of direct proportion. The worker will get more money for more days of work. To earn 1,200 rupees, the number of days he needs to work is 12. So to earn 1 rupee, we need to divide both sides by 1,200 to give 12 over 1,200 days. Which is equal to 0.01 days. And therefore, in order to earn 40,000 rupees, we need to multiply both sides of the previous line by 40,000. And of course, 40,000 times 0.01 is 400 days. So 40,000 rupees can be earned by a worker in 400 days. Now let's take a look at some inverse proportion examples. Suppose 16 men can build a wall in 48 hours. How many men will be required to do the same work in 32 hours? Let's solve this. This is an example of inverse proportion. More men means less days needed. The number of men building the wall in 48 hours is 16 men. So in order to find the number of men required to build the wall in 1 hour, we multiply 16 by 48, since we have divided 48 hours by 48, and we're discussing inverse proportions. So in order to find the number of men required to build the wall in 32 hours, we multiply the 1 hour by 32. Therefore, we divide the 16 times 48 by 32, since, as we said earlier, we're discussing inverse proportion. The 16 and the 32 cancel as shown to give a half, and therefore the number of men required to build the wall in 32 hours is 48 over 2 men, which is 24 men. Let's look at another example of inverse proportion. Suppose 15 typists can type a book in 30 days. How many days will it take 5 typists to type the same book? This is another example of inverse proportion. Less typists means more days will be required. The example informs us that the number of days required for 15 typists to type the book is 30 days. Therefore, the number of days required for one typist to type the book is 30 times 15, since we've divided 15 typists by 15 to give us one typist. And of course, we're talking about inverse proportions, and this is why we've multiplied one side and divided the other side. And finally, in order to find the number of days required for 5 typists to type the book, we multiply the one typist by 5, but then we divide the number of days, in other words 30 times 15, by 5, in order to find the number of days required for 5 typists. And here, as you can see, the 15 and the 5 cancel to give 3/1, which gives us 90 days. So 5 typists can type the book in 90 days. Now let's take a look at a final example of inverse proportion. Suppose 25 builders can build a cabin in 10 days. How many more days are required if 5 builders left? As we mentioned, this is an example of inverse proportion. So less builders means more days needed. As per our example, the number of days for 25 builders to build a cabin is 10 days. So the number of days for one builder to build a cabin is 10 times 25 days. Because of course we're discussing inverse proportion. Finally, in order to find the number of days required for 20 builders to build a cabin, we divide by 20. So we have 250, which was of course 10 times 25, divided by 20, which equals 12.5 days. This brings us to the end of this session. If you have understood its contents, you should be able to define the ratio of two quantities, define and identify direct and inverse proportion, and solve real-life problems involving direct and inverse proportion. Thank you very much for listening. In order to understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.